Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to talk about the mechanism of the electrophilic substitution in benzene. The reason behind that is benzene or the aromatic compounds are the one that shows substitution reaction. But talking about substitution reaction when it comes to in terms of benzene shows basically electrophilic substitution reaction. And as we know that earlier also that addition reaction is not taken place by benzene with a normal condition. So now let us see what are the mechanisms that takes place in electrophilic substitution of benzene. So let us talk about that. So now we are going to talk about the mechanism of electrophilic substitution in benzene. But to understand that why actually the benzene shows the substitution reaction and rather than that of the addition reaction in spite of having carbon-carbon double bond in it. The reason behind that is because as we know that because of the benzene ring that is being in the cyclic form, and that's the reason because of which the pi bonds that are being in the benzene ring, they are not on the same position but they are delocalizing, and because of which this will create a very hybrid structure, and that's the reason that if we see a carbon-carbon single bond in a normal alkane, so in that case the carbon bond is very much longer compared to that of the carbon-carbon double bond. But the benzene carbon-carbon double bond means the carbon-carbon double bond of the benzene, it has been found to be having 1.40 Armstrong. So which is between the carbon-carbon single bond and the carbon-carbon double bond distance. So that makes us to understand that benzene is basically a hybrid structure between the carbon-carbon single bond and carbon-carbon double bond, making this to be known as that benzene is very stable also depending on because of it has the delocalized electron, and those delocalized electrons are not on the same carbon atom but are revolving around every carbon atom, which makes the benzene unexpectedly very stable. And talking about the delocalizing electrons, or when we are talking about the p orbitals, and as we know that p orbitals consist of electrons, so because of which they overlap in such a manner that they undergo that is lateral overlapping. And the lateral overlapping is somewhere like this one, where I would say they overlap in this manner and not in this manner. So that is the reason because of which the pi electrons or the p orbitals they combine to each other so as to form a pi bond, and that is the reason that it is not only localized on a one position, as I said, it will revolve around in the that is they will delocalize, and that is the reason the p electrons or the pi electrons that we could observe is above the plane of the benzene as well as below the plane of the benzene, making this to be more stable. And that is the reason because of the electron are not being localized on one position, that's the reason the addition reaction don't take place and don't take place very easily. So that is the reason only one option is being left because of the electrons that are being revolving in that is in the ring of benzene, as you could see, that is in hybrid structure of benzene also. So because of which it will try to do a substitution reaction that is basically electrophilic substitution reaction. That is the reason that benzene ring acts like a negative while it will allow a positively charged species to attack on that so as to get substitute so as to form a substitution reaction. So that is the reason that we are going to talk about the what are the mechanisms that are involved in the electrophilic substitution in benzene. So basically there are two steps that are involved in this mechanism. So talking about the first step, that is the step number one, or these are the main two things that I am going to talk about, that is step number one and step number two. So talking about the first one, that is the formation of carbon takes place. Yes, let me explain you this. Suppose if we have a benzene ion that has been represented in the structure like the Kekul's structure that we have represented in that way. So suppose this is a structure of benzene that I have mentioned over here, and because this ring, basically the inner ring, as you could see, basically it consists of the pi bonds as well as it will include obviously that is pi electrons. So therefore they will revolve and they will not be in the same position, because of which the whole hybrid structure will have a very stable structure also, because of the electrons they are delocalized, and because of which we could see that suppose an electrophile is the one that has to substitute in this benzene so as to remove an hydrogen. So it takes two steps. So that is the reason that I am talking about the first step, that is formation of carbon. So suppose if an electrophile And what is electrophile? Electrophiles are those species which are itself positive but have the capacity to attract towards the negatively charged species. So that is the reason they are known as electrophile. Electro means negative and phile means loving. So the one which is loving or which has been attracted towards the negatively charged, and their species are basically known as electrophile. So therefore here I have represented an electrophile with E and having a positively charged. So this represents electrophile. And now what will happen in this case is, according to the Kekul's model that I have written over here. So in this case, because it consists of pi electrons, so what will happen is, among the 3 pi bonds, suppose one bond is the one which is composed of the 2 pi electrons, and that will attack on the, suppose, on this electrophile. So what will happen is, because this process is a very slow process, one thing that I want to explain, that this process is a slow process, and because of which we could see that the electron and this electron, as you could see over here, this electron will be combined with this electrophile, that is E plus, so as to form a bond between them, that is this carbon and this carbon. And we could see that the carbon in this carbon, the electron has been lost, because the electron has been lost towards the so as to form a bond between the electrophile, that is E plus. So therefore now this carbon is now becoming a carbocation. The other bond will not change, it will be remaining in the same position, where I could see that here is the formation of that is E plus. So therefore either I could say that the double bond would have been removed from this side, or it had formed the bond from this side also. So suppose if I would say that this electron has been moved on this that is electrophile, so therefore the bond that will take place over here is this one. So bond has been formed over here, and all the carbon atoms consist of at least one hydrogen atom. So that's the reason that even this carbon would consist of a hydrogen atom over here. So I would have writing over here. But talking about one electron has been lost from this thing. So that's the reason, as you would see, that every carbon atom in the benzene ring is forming basically hybridization of sp2 hybridization, as you know. But now here, as you could see, because the carbon is forming a single bond, and that's the reason that the carbon that is being here is basically, I will write over here as sp3 hybridized carbon atom. And that is the reason that because of one electron has been lost in this case, so therefore we could easily write there is a kind of positively charged that would appear over here, and this reaction is basically a slow reaction or a slow step process. So that is how we have made a conclusion that when an electrophile is being approaching towards the benzene, and the benzene has delocalized electrons in it, and because of which a bond between the electrophile and the benzene ring takes place, and meanwhile we could see that the formation of carbon cation is also being formed. And that is the reason a positive charge is appearing on this carbon atom, making that carbon atom, which is basically carbocation, to be sp3 hybridized, and the other carbon atom would be sp2 hybridized. So this is the thing that we have got to know. But talking about this one, that is this is basically benzene that we know. And whenever an electrophile will approach the benzene, then the formation of a carbocation will take place, and that's the reason a name is being given to this kind of complex that has been formed over here, and that is basically arenium complex. Because arenium, as the name suggests, that arenes are basically the that is aromatic compounds. They are known as arenes, and in this case also it is a kind of an aromatic compound which possesses a positively charge. So therefore the name is arenium complex, and the reason the name is complex because it is not the final product that we have got. So it is a mixture of an benzene and an electrophile. That's the reason that it makes it to be called as a complex. But the reaction doesn't stop over here, and it will proceed. And the proceeding of the reaction will make so as to form basically an electrophilic substituted benzene. But before that, let me explain that similarly, when a negatively charged electrons, that is a pi electrons, they revolve in the benzene ring or within this section, as you could see. So if negatively charged electrons, if they get delocalized, so similarly to that, the positively charged species also undergoes to delocalization, and that's the reason to make it stable, even they will be also delocalized in the ring, and forming this to be known as a resonating structure. So what is resonating structure? Let us learn about that.
So now we are going to describe what are the resonating structure of this carbocation or this arenaeum complex. So let us talk about that also, and then we will move on to the step number 2. So therefore the structures, or that is the thing that I am going to talk about, that is so the resonating structure, that is what I am going to talk about, would be of arenaeum complex. So therefore it could be written as in this form. It will be very similar to that of the thing that we have got a product as in first step. So therefore we could write it here as a double bond over here, and here the electrophile was been substituted, and the carbon-carbon that is bond, and that which possess basically the sp3 hybrids, or we could say as a carbocation, is basically present over here. And even it consists of a hydrogen atom that I am representing over here. So this is the arenaeum complex that we have got, and the thing that we have to do is we will name it as number 1. So let me name it as number 1. And suppose the resonating structure will happen, and that's the thing that the delocalization of electron also would take place. So as you could see that there is a positively charged carbon atom over here. So as to neutralize it, what will happen, since electrons are the one or the pi electrons are the one that are been delocalizing, so therefore in this case we could see that this electrons that are been present over here, they will delocalize on this carbon atom so as to neutralize this carbon atom, but meanwhile they will turn into a positively charged carbocation. The reason behind that is the electron has been removed from this carbon atom and it has been substituted, or it has been delocalized to this positively charged carbon cation, and making this to be neutralized while this carbon to be positively charged carbocation. And that is the reason that we could see another group also that could be written as in this form, where there is no change in the structure of benzene, because in resonance also, as we have got to know, because there will be no change in the position of the atoms, but only change in the position of the electrons or the pi bonds that we have made in concern. So therefore here also the hydrogen atom is over here, and meanwhile the electron is also over here. So in this case, suppose the double bond of this case would remain the same itself, because suppose if this has not undergo the delocalization, so therefore it would be placed here itself. While as here we could see that because of the double bond that has been shifted over this carbon atom, make it carbon number 1, 2, just for an instant, 3, 4, 5, 6. So now the double bond can be written between the carbon number 1 and carbon number 6. But the carbon number 2 will have a positively charged, that is carbocation. And now, so as to make this as stable also, so what will happen is the delocalization would take place in such a manner that this electron, it will shift over there on this carbon atom so as to, that is neutralize the carbocation, and that is the reason that it will form a bond over here, and we could see that the positively charged carbocation will be represented over here. So therefore the structure could be represented as in this way, that is and here the electrophile atom is also been present over here. And talking about the hydrogen atom is also over here, and this is the double bond that has been formed from the resonating structure, so therefore it would be still as here it is, and because of which here the double bond has taken place over here, so therefore I would write, or I would represent over here like this one. While meanwhile if we could see that this electron has been shifted on this carbon cation, that is carbon number 2, so therefore we could see that carbon number 4 is now turned into a positively charged carbocation. And now for this to be stabilized, what will happen is, suppose if another hydrogen is also been present over here, because as we know, because the benzene carbon are also containing one hydrogen each, so therefore if suppose if this consists of an hydrogen atom, so what will happen in this case is, because of which this electron, it will come over here so as to, basically we could say in this manner, so as to stabilize this that is structure in terms of an it should resemble to that of a benzene ring, and that's the reason that we could see that the resonating structure would occur in such a type that the benzene ring would be followed over here. And meanwhile, since the electrons are been delocalizing, so therefore they are delocalizing in such a manner that we could see that there is a possibility of a kind of a positive charge, because as the positive charge also gets delocalized, so therefore this is the positive charge species that we could get over here. An electrophile is the one that has been attached on this carbon atom. So again, the positively charged species would be over here, and that's the reason that we could see these are the resonating structure. So I will name this as carbon number 1. This will be 2, or resonating structure 2, and this would be suppose 3, and ultimately this is the one that is the 4th one. And now this is nothing but the resonance hybrid that we have got to know, and ultimately we'll get even the positively charged, they will delocalize because of the electrons, that is the pi electrons, even that are been delocalizing, so making this to be created as a positively charged species in this case. So the thing that we have to do is, yes, we have to move on to the next step. And what is the next step? Let us talk about that also. So the second step that I am going to talk about is basically removal of the proton, or in this case also as we have got to know that in this case, as you could see, because the hydrogen atom that has been over here, that is being removed, and then only the process will be very much stable, as well as we could see that there is a positively charged species over here, but that is not been neutralized till yet. So it will be neutralized only when the electrons will be the electron of the hydrogen will be involved in this case, so as to neutralize this thing. So that's the reason that we have to remove the hydrogen. So how the hydrogen would be removed? So that is the thing that I am going to talk about. So in this process, the thing that I am going to talk about is basically removal of hydrogen atom, or basically removal of a proton. Proton is nothing but the H plus ion. So in this case, the thing that I'm going to represent is I have to draw the structure of that has been formed in the as a product over here, as you could see on the first one. I'm going to use this same product, and for which I am going to represent that hydrogen has been removed. So therefore, the structure that was being mentioned on the step number 1, that could be written as in this form also. That is what I am writing over here, having a positive charge species on this carbon atom, and hydrogen atom was also been attached over here, and meanwhile the electrophile was been attached on this carbon atom. So this is what we have made it, and even the hydrogen atom will also be attached over here also. So now the thing is, we have to remove the hydrogen atom, and that's the reason that we could get a stable product. So in this case, what will happen is the process that would take place, it would be basically a fast process, and that fast process will be because of the nucleophile. Suppose if it has been attached, or that has been introduced in this thing. So therefore, the nucleophile that is represented by Nu minus, so that would be able to remove the H plus atom. In this case, what will happen is the H plus atom could be easily removed, and because of which, one thing that we could notice that so as to stabilize this positively charged species, this would basically this electron of the hydrogen that will go over there, that is on the positively charged carbocation, so as to form a bond over here, and meanwhile the nucleophile would be able to remove this hydrogen. So this hydrogen would be removed in the form of, that is, NuH, and the thing that has been remaining with us is basically the benzene ring along with the electrophile. So that is the thing that we could observe, that this is the benzene ring, and see the double bonds are in this format, where we could see that hydrogen atom was being here, and meanwhile this hydrogen atom that I have represented over here, this is this hydrogen atom, so making this to be noted as NuH, and the rest of the part that has been remaining is the electrophile. So therefore this is the electrophile that we have. So this is basically is mono substituted benzene, and that is the reason that this E is representing an electrophile. So therefore this is basically an electrophile substituted benzene that we have got, and the reaction that takes place over here is a very fast process, because the nucleophile is the one that would rapidly remove the hydrogen atom or hydrogen ion, and that's the reason that we could get the possible product that we are getting over here. So now talking about the next one, that is what are the different kind of nucleophile that we could get. So for example, if I would say that is in during alkylation or during acylation, that is the reason that we are going to talk in the future also. So in that process, basically AlCl4 minus is being used as a nucleophile, and talking about in nitration process, there's HSO4 minus is being used as a nucleophile. So even that reaction that we are going to observe. So this was the basic mechanism that I wanted to explain you. So that is the thing that I wanted to explain you. So thank you friends for watching this video, and I hope you have understood this video, because this mechanism plays a very vital role in understanding that what are the different kind of reaction that could take place during a substitution process. So thank you friends for watching this video. Share this video with your friends, and just don't forget to subscribe Ekeeda channel. Thank you so much.